Let's learn in this Lightboard session about AKS, Azure Kubernetes Service Architecture. We will not cover all the aspects or all the components, but we'll talk about the private cluster versus the public cluster, the configuration for the ingress using the load balancer, how to expose our services to the end users, and how we can enable the cluster administrators or the DevOps pipelines to connect to the cluster and so on. So let's get started. So with an AKS cluster that is almost the same Kubernetes cluster but hosted and configured as a managed service within Azure, we would have, let's say, the same components as in a Kubernetes cluster. So typically the main component that we would have here is the Kubernetes API, which will be exposed through the control plane. So with this component here, we would have this famous control plane. This control plane actually will contain 4 components. The main component that we'll have here within the control plane would be the API server. So from here, we would have this API server component, which is actually the entry point or the front-end service for managing the Kubernetes cluster. This API server will be exposed on a public or private endpoint. So by default, when we create Kubernetes cluster, that would be a public cluster. It means it would have actually a public IP that will expose this API server. And it could be also a private cluster. Private, it means that this API server will be exposed through a private endpoint. Or it could be also exposed privately, but using the VNet integration. This is a new feature in AKS, and it enables you to get through that VNet integration. Actually, it would have an internal load balancer, ILB, that will go to expose this endpoint to access that API server. And as we'll see later, this endpoint will be used either by the worker nodes and also by the cluster administrator who will need to access through this exposed endpoint. The other components that we'll find inside the control plane would be the scheduler, controller manager, and also would have also the cloud manager. The cloud manager here, its role actually is to go to connect to the Kubernetes or to the Azure API. So this component is the one that go to talk to Azure for provisioning resources. So because when we create the cluster, actually, sometimes we need to create other resources like provisioning the load balancers or provisioning some storage accounts and so on. So those will be done through this component right here, the cloud manager. That's the way how AKS can provision those resources automatically for us. In addition to these 4 components, we would have actually a 5/5 component, which would be the database for all of this configuration, which is the etcd database. The database, I put it outside the control plane because here we suppose that this control plane actually is at the end, it's a virtual machine and it's up to Azure to configure the components inside that VM. And the etcd database does not live within this virtual machine. It's a configuration outside that control plane. And of course, it's managed by Azure. So it means all the replication will be also managed by Azure. So there are 3 replica of that etcd backed up by Microsoft Azure Cloud. Now inside the Kubernetes cluster, we're going to deploy our applications in forms of a pod or containers. So those pods will not be deployed inside this control plane, but they will be deployed inside the worker nodes. So the worker nodes, that's another component within the Kubernetes cluster, and those are at the end are virtual machines. So those are VMs. Actually, we call them node in the Kubernetes jargon. So we might have one or multiple nodes within a cluster. So I'll draw here 2 nodes, for example. And those nodes will be part of VMSS in Azure. So the virtual machine scale set, that's a group of virtual machines. So that could be one or many. Let's draw here 3 VMs in this VM node. So let's say this is the VMSS at the end, or the node pool, call it also in Kubernetes. And I might have within a Kubernetes cluster, I might have one or multiple node pools. So I'll draw here 2 node pools. Why I might have one or many? Actually, there are 2 reasons. First is the difference between those node pools. We have actually the user node pool and the system node pool. The system node pool is supposed to be dedicated for the Kubernetes platforms or for the Kubernetes pods. Those are like the pods that runs inside the kube system namespace, like the core DNS or the kube proxy and so on. So it's better to dedicate a node pool for these applications because they are critical, and if they stop running, then our cluster will go in a failed state. And then we should have a second node pool dedicated for our applications. So with this, we separate in terms of hardware, the resources dedicated or the VMs dedicated for our application and other ones dedicated for the Kubernetes pods. That's reason number 1. Reason number 2 is to be able to mix and to have different SKU for those VMs. So this is because this is a virtual machine scale set. It should, all VMs here should have the same SKU. But what's about the workloads that needs, for example, to use Windows virtual machine and Linux virtual machine and some other SKU or family VMs that needs to use the D virtual machines, for example, or the F virtual machines that are CPU optimized, or the E VMs that are memory optimized, or what if I want to use some VMs that have the GPU enabled for my AI slash machine learning applications. So having this possibility to create multiple node pools with different virtual machine scale set will enable me to get this flexibility. So within those virtual machines, we would have actually the typical stack installed here. So we would have the container runtime, which is today container D. It's used to be Docker, but nowadays it's a container B starting off Kubernetes v1.21. So that would be installed in all the worker nodes. And then we would have other components like the kubelet. The kubelet actually will not run as a container, but it will run as a process within all the virtual machines, and its role is, for example, to pull the images that we request from the registry, for example. So that's going to be done by the kubelet. And it will go to also manage the communication between those worker nodes and the control plane to get data and also send some data there. Another component that would be the kube proxy for managing the communication between pods that lives inside those nodes. So that would be the kube proxy. And then inside those VMs, we would have our pods that will live here, either deployed as a pod or as deployment. So we would have one or many. They will live inside specific namespaces and so on. And the same goes for here. Now, the way for us to deploy those pods, if let's say here I have my cluster administrator, either that could be a cluster admin or the DevOps pipelines that will run in order to deploy applications here. Actually, they will go to use some YAML config file. They will write the YAML config for creating those deployments, the services, the pods, the ingresses, and so on. And then they will go to deploy it into the AKS. It means into this endpoint for the API server through the command line kube control. So through kube control, because here we add security to this cluster, so maybe we have already enabled the Azure Active Directory authentication. So we can enable that feature so that each request to the API server should be authenticated and then authorized by AKS. So this request will go up to here in order to deploy applications into my cluster. Then the API server will read that request, persist that data or that YAML inside the etcd right here, and then the controller manager and the scheduler will go to schedule that that deployment into the worker nodes. And here we don't have yet that matching or that connection between these two components. So actually that would be done in two different ways. So either if we have a public cluster, it means this public IP exposed publicly. So this way, those worker nodes will communicate through that API server through its public IP. So that communication will go through the internet. So it's better to use a private cluster, either through private endpoint or through the virtual network integration. And with that option, now the communication will be done through that private endpoint. And that private endpoint will live inside a virtual network right here. So we would have this endpoint here that will be mapped into a virtual network. So we would have a VNet here, or a subnet there, and that private endpoint will be available in this subnet. Typically, this private endpoint or this internal LB will have the address 10.0.0.10. And then those worker nodes will be able to connect to it because they will be connected to the virtual network themselves. The VMSS will be attached to that virtual network. So all of these VMs will have access to that endpoint. Great, so now those admin and those DevOps pipelines will go to deploy the application into my cluster that will go to create the different objects like the pods, the secrets, and so on. Secrets, the config maps, and all the Kubernetes objects that you know. So let's say now, for example, I want to expose those applications to my end users. So I would have here my end users, my very happy users here. They will go to use their browsers. So they will go on the internet, and then they will use their very modern browser like Internet Explorer 6, not use it. So then how this user from here can access those pods from here. So in Kubernetes, we can expose those services either through public load balancer. So what I can do here is that I can create a service of type load balancer or public load balancer. And with that, we would have a new public IP address will be created and attached to our load balancer. And by default, actually, we would have our AKS cluster that will come with a public load balancer by default. So we would have here a load balancer that is created by default. You'd have only one load balancer for the AKS, but there are a feature here today in progress that will enable you to define multiple load balancers for your clusters. So all of those VMs actually will go to connect to that load balancer. So that LB actually will be used for the two senses here. So either it will be used for the external traffic or for the egress traffic, because those VMs or those pods inside, maybe they will need to connect to the internet, or VMs here need to get the Linux updates, for example. So they will connect through that load balancer to go to the internet. I can use that same load balancer to expose publicly my service to my end users. But better, what I can do here within Kubernetes is to use the ingress object. So what we should create here is an ingress object. Ingress will define the routing into the service, and then from the service it will go actually to reach the different pods, because it will maintain the private IP addresses of these pods. And that ingress actually should be implemented through an ingress controller. So we would have something like Nginx ingress controller, or the Azure Application Gateway ingress controller that is Azure native resource. So with that, when we create that ingress controller, it will go to create or to provision a public IP address. That public IP address will be exposed to the load balancer actually. So I would draw it something like this, public IP. And then my users will be able to connect to that public IP, but I don't want to give them an IP address. So what I can do in this case is that I can add here some DNS configuration. I can configure that using Azure DNS, okay, where I can go to map my domain name into that public IP right here, so that those users will go to connect to my DNS or to my domain name defined inside Azure DNS. Great, so this way those DevOps and those admins will go to deploy the applications here. That config will be saved into the etcd, then the config will be applied into the worker nodes, into the different worker nodes. Of course, here I can choose through the node and pod affinities where to deploy exactly those pods. So if I have a user node pool and I want to use it, then I will define some taints here to make those pods deployable only to that user node pool and not to the system node pool. Another thing I want to add here for those pods private IP addresses. So depending if we are using KubeNet, Azure CNI, or now we'll have another option that is Cilium. So if we are using KubeNet, then this means those pods actually would have a private IP addresses defined within a subnet or within an internal virtual network to the cluster, and that virtual network is only addressable within the AKS cluster, is not addressable from outside or from my VNet. I cannot access to these pods. But however, if I'm using the Azure CNI or Cilium without using the overlay network, then those pods actually will have a private IP address that will be mapped into the VNet. So here this one would have an IP, and the other pods also would have, each one would have its own IP within the subnet. And again, if we are using Azure CNI or Cilium with the overlay mode, then those pods will not have IP address within that VNet. They will use the internal Kubernetes network to get an IP address from there. And then the Azure route table will be used in order to make that communication between those different pods possible. I want to add here about also the availability zones. So when we have drawn those node pools, so a node pool can live in one or multiple availability zones. Availability zones are a group of data centers within the same region. So when I say, for example, West Europe, that's the Netherlands, and there we have actually 3 groups of Azure data centers. In each group or on each availability zone, we have one or multiple data centers. And those availability zones, actually, there are a distance between them, like between 5 to 20 miles. So that's first step to secure your workloads from data center or from zone failure. So those node pools could live in one or multiple availability zones. And if you have requirements for a higher SLA, then you would enable using the 3 availability zones along with the uptime SLA. Another thing about the managed identity, so when we create an AKS cluster, actually we would see that there is already a managed identity created for us. So that would be, let's draw that here, managed identity. That managed identity will be attached to this VMSS. And that managed identity will be used in order to connect, or for the kubelet. Actually, it will be available for the kubelet component so that it could connect to the ACR, Azure Container Registry, in order to pull the images. So that's the default identity. It will be available in all those node pools, and all the pods from here, they will be able to access it. However, we can also have many other managed identity within an AKS cluster, mainly a managed identity that will be available or that will be used by the control plane. So remember, this cloud manager actually needs to connect to the Azure API in order to provision some resources. And maybe for that reason, it should use a managed identity right here. So we should give that managed identity the right airbag roles for for that managed identity to be able to create the virtual network, create the load balancer, create those VMSS, create those public IPs, and so on. So previously with the old versions of AKS, we used to use the service principal to manage the authentication with other Azure services. Now it's of course recommended to use that managed identity instead. Then when we enable other Azure plugins or AKS plugins like the log analytics or the Azure monitor to get the logs and metrics from the cluster, that will use or that will also create another managed identity used for that objective. And then if we use, for example, the secret source CSI driver, if we enable that plugin, it will create its own managed identity also. Great, I hope this explanation was helpful for you. Thank you.